My name is Ahmed Ubabana, and this is the fourth screencast for Mr. Morrison's Physics 101 class. So for this assignment, we have to figure out the coefficient of friction between in two situations. In the first situation, we have a car that is sliding on ice, and in the second situation, we have a guy who is sliding on ice, and we have to figure out the coefficient of friction for both cases. First steps first, we draw our free body diagram. And in this free body diagram for the car, we have the normal force acting upwards, the weight acting downwards, and these forces are going to cancel each other out because we have no net movement in the y coordinate. However, in the x coordinate, we only have the force of friction. The force of friction on our free body diagram. We establish our coordinates. We know that upwards is going to be positive, and we know that to the left is going to be positive. We know that friction is then acting on the opposite direction to the right because it opposes motion. First steps first, in our problem solving method, we list our knowns. Our unknowns, the change of x is going to be 8 meters because we can calculate that from the grid spacing in the video. We also know that the time is going to be 3.34 seconds, and we calculate that from the conversion ratio of 30 frames per second. We know our unknowns for now are the initial velocity in the x-coordinate and the mu sub k, the coefficient of friction. So in our first steps first, we figure out the velocity, the initial velocity, and we use our equation of motion here of x equals x initial plus 1 over 2 times. In this case, it's just going to be v initial, because we know that v final is just 0, plus 0 is nothing, so times time. We crunch the numbers and we get the initial velocity is going to be 4.79 meters per second. Second step is we can use this initial velocity to plug it into yet another equation to figure out the acceleration. In this case, it's just going to be negative 1.43 meters per second. Going over here, we know that the mu sub k is going to be the acceleration divided by the gravitational field constant, and that is because in this case we're only concerned about the x coordinate, because we already stated earlier that the y dimensions are not really important in this problem because they have no effect on friction. Here we know that net friction is negative because that's how we set up our coordinate system, and we know that the sum of the forces in the x direction are going to be mass times acceleration of x. The only force in the x direction is just the force of friction, so the force of friction is going to be mass times acceleration. We know that we can substitute mu sub k times the normal force, which is the force of friction, which is going to equal mass times acceleration again. We can also substitute mass times gravity for the normal force, in which case we can state that mu sub k equals acceleration in the x coordinate divided by the gravitational field constant of negative 9.81. Basically, from here we go back up, and when we crunch the numbers, we get that the coefficient of friction for the car is going to be 0.146, and we know that the coefficient of friction is not going to have any it's just going to be it's not going to have any units because that's the way it's supposed to be. We also know that the coefficient of friction is always between 0 and 1, in which case, in this case it is, so we're at least on the right path in that regard. So just to recap, we started by our free body diagram, used our set up the coordinate system, the y and x coordinate system. We applied Newton's second law of the sum forces equaling mass times acceleration in both coordinates, and eventually when we crunch the numbers, we get that the coefficient is 0.146. For the guy sliding with his shoes on the ice, we use the same exact method, just the numbers are just going to be a little bit different. We know that the time frame is going to be 3.3 seconds, just counting how many frames it takes him from when he starts sliding to where he stops. And we know that the change of x, the displacement, is going to be 7.5 meters. Again, No, we know this just because we can calculate, the grids in the video, which we know that 0.5 meters is equals 1 grid. The free body diagram here is we also have just normal force upward, the weight downwards, and the only force in the x coordinate is going to be the force of friction. We know upwards is positive, to the left is positive in the x coordinate. Again, the first step is to find the initial velocity, which is in this case 5.5 meters per second. From there we can use that initial velocity plug it into our second equation here, and find out that acceleration is negative 2.01 meters per second squared. Also, the mu sub k in this case is just going to be acceleration in the x coordinate divided by gravity, and we're not concerned about the y coordinate in this case, because we're not going to use it to solve anything, because the y coordinate is the normal force and the weight cancel each other out. So here again, mu sub k is just going to be the acceleration, which we figured out, divided by the weight, or the gravitational field constant of gravity, which is going to be negative 9.81. Negative divided by negative equals positive, and mu sub k in this case is going to be 0.205. Again, coefficient of friction doesn't have any units, and it is between 0 and 1, so it seems that we're on the right path. So basically that's the end, and the first coefficient of friction was 0.146. The second is mu sub k. The second mu sub k is 0.205, and that was the fourth screencast assignment.